Now, let us all welcome our next SINCON 2021 keynote, Blind Spots of Platform Security, Hardware and Firmware Challenges. Please welcome Alex Matrosov, founder and CEO of Binary Inc.
Good morning, Singapore. And it is a big pleasure for me to be here on the virtual stage of SINCON 2021. And I'm happy to deliver my keynote, which is focusing on blind spots of platform security. And we will talk today about the hardware and firmware challenges. But my name is Alex Matrosov, and I'm well-known offensive security researcher, spending almost 2 decades focused on reverse engineering and detection of low-level threats, and basically breaking the hardware and firmwares. I've been working for the companies like Intel and NVIDIA and some others. And actually, currently I founded my own company called Binary, focused exactly on these blind spots and try to fix the industry and get it patched. So let's talk about what the challenges are. And if you think about, we spent decades on targeting detections on operating system level. And that doesn't mean we don't have the threats which is evolving on firmware and hardware space. It is actually a big mistake from the industry. It's been constantly overlooking and ignoring such of the spaces, but now it is actually right timing to focus on that problems. And in my keynote, I will be discussed today why. So if you think about like in the offensive security industry, we just scratching the surface on what we try to detect on the hardware and firmware level. And of course, like modern persistent techniques, it's always evolving and try to invent new techniques to bypass endpoint solutions or stay not detected for a long time. And if you look on evolution of the persistent technique, it's been always some sort of like a challenge between mitigations and modern persistence complexity. Because if you look on this figure, you can see, so we have a rootkit, which has been pretty actively before attacking and hooking on operating system level the code, but when the code signing policy for the kernel model being involved, like these mainstream threats move to the lower stack and try to infect master boot volume records and some other stuff, which is actually bootstrap some code before the operating system get control. And basically, it allows the attacker to be in the place where at the time not been much solution looking effectively to detect such of the threats, right? And then actually secure boot came onto the radars where it is create some integrity of the boot process, and bootkits became less effective, right? So, and it's been a time where attackers need to look and find the new spots, and it is exactly at the firmware, right? So BIOS implants is actually less rare than you think about. And even nowadays, attacking the sign-in driver and bootstrap your code to the kernel mode, also a potential scenario for the attacker to bypass code sign-in policy, because you can execute the code over exploiting the vulnerability in a legitimate driver, right? Or use legitimate driver if it is providing some functions for abuse this driver and deliver malicious code to operating system level. And that's a good topic, picture where we can see how moving down from the operating system to the hardware, we actually have less mitigations, less detection techniques, and actually persistence and the quality of the persistent techniques is growing exponentially. Also, that's a very good statistics about how many ETR bypasses we have in the wild. If you think about modern EDR, endpoint detection and response solutions, all of them based on APIs, which is Microsoft provide with ATW interfaces, right? And if you have an ability to bypass such of the interfaces or like stay under the radars of this telemetry system, you can be undetected by many of endpoint solutions nowadays. And on this chart, we can see how many vulnerabilities grows by the last 2 years, right? So in 2021, just actually overloading us with multiple vectors, which is can bypass by design TW telemetry collection and endpoint solutions. Actually, about that, my colleagues from Binary will be talk about on the next week at Black Hat Europe. And to be honest, it's very big problem for the industry where we have unified interface, which is cool, right? So we have unified interface, and from development perspective, it's very effective way, but also unified interface means bypass once, work for whole industry, right? And such of the problems also exist in the firmware space, and we will talk about that a bit later. But let's focus on how actually Mitra attack providing us some guidance about the firmware corruption threats and the mitigations is actually exist, right? So it's actually doesn't provide much guidance. We have a boot integrity, we have a privilege account management and update software, right? So you need to use the recent BIOS, you need to basically reduce the privileges of the user and check the integrity of your BIOS. But to be honest, integrity doesn't provide much visibility. Even the integrity failed, so you don't understand what is caused this failure, right? And OS privileges doesn't equal to firmware privileges. Basically, yes, you can reduce a bit attack surface, but you will be not eliminated. Also, updated firmware doesn't mean it is secure firmware because based on our statistics from Binary, actually one-day vulnerabilities can survive up to 2 years in many actually enterprise vendors. And that's kind of scary, right? So broken integrity really doesn't tell us much about an impact tool. And we need really to call the industry and reinvent how we think about such of the detection and mitigations for these problems, because the similar approaches we currently applying on operating system level doesn't work effectively on the firmware and hardware space. But let's talk about the threats actually we're detecting right now in the wild. And this screenshot made from the Mosaic regressor from IDEPRO. And to be honest, Mosaic regressor has been one of the threats detected in the last year by Kaspersky Lab. And interestingly, such of the threat being based on the even older implant, firmware implant developed by Hacking team and called RK Loader. To be honest, Mosaic regressor developers didn't remove indicator, which is caused the infection indicator for Hacking team, and it is UEFI variable with a constant name FTA. And this 5 years old indicator, why Mosaic regressor takes a while to detect and actually provide guidance for the industry for such of the threats. It is ridiculously long time, and to be honest, it contains old indicators and it's stay undetected, which is exactly proves the statement which I told before. We don't have effective tools for detecting such of the threats, right? Another example, it is abusing the bootloaders of operating system and basically provide some sort of In another example, it is actually some of the POCs get developed on top of modern EFI bootloaders when it's tried to show some ransom screen with like a pretty simple output of the strings on in UEFI console output. So basically, this being detected by ESET, but to be honest, it's being found on GitHub with source code. And I hope the ransomware will be not showing up in the firmware space because it is much more scary than operating system level because it can cause actually critical failures for the systems. And to be honest, I demonstrated some POC about how from operating system level to the firmware, the attacker can persist in Black Hat Asia 2017, and it's been in Marina Bay Sands in Singapore. Hopefully I will be come back there soon. It is awesome venue. And where it's been showing how actually the attacker can persist, survive, and potentially it's quite scary vector for ransomware, right? But let's come back on some nowadays news and what is happening in the wild last month, right? So it is 2 threats which is actually being detected in the wild. One of them, it is Finfisher, state-sponsored, government-sponsored attack detected by Kaspersky, which is being used in the module where it is a bootloader with some very minimal modifications to basically bootstrap the code for providing to the operating system malicious payload. And this is a classical bootkit because it is abused the bootloader, not exactly the firmware. And another one, it is being eSpectre, which is being detected by antivirus company called ESET. And it's pretty similar techniques get used by both of these attackers. And basically, eSpectre also interesting because it stay under the radars almost 9 years. And it shows exactly the problem. Industry not ready to detect the threats which is under or below the operating system level, right? So where it became very complicated to detect such of the threats. So, and if you think about which were being attacked by eSpectre and Finfisher, it is exactly bootloaders, which is responsible for actually loading Windows kernel and initialized rest of the code during the boot. So, of course, secure boot will save us all, right? So, but on the practice, even secure boot, it's not that hard to bypass. And we'll talk a bit later how we can do it with modern attack vectors in the firmware. So, but to be honest, these techniques, which has been used in the Finfisher and eSpectre, it's not new, and it is even been discussed in my book, which has been released a few years ago. And the techniques originally actually being presented in 2012 by researchers, and only now we get actual detection for that, which is quite scary because industry looks like not ready for more complicated threats, which is inside the firmware. And this is actually a snapshot of the code from the entry point of one of the bootloaders from the eSpectre. And we can see clearly here is a position-independent code where the attacker tried to actually modify the bootloader, but stay stable on execution flow and will be independent on relocations on whatever changes in runtime can happen. So basically, this code obviously looks like not a standard code produced by the compiler, but still why for detection such of the threats takes a while. And it's no easy answer. To be honest, the industry have a lot of other problems, but back to the firmware and hardware, it is some disconnection between operating system and actual hardware and firmware threads, because it's completely different worlds and need very specific expertise to develop effective solution for that. And of course, like endpoint vendors don't really focus on firmware specifics because they try to cover the whole stack, and it is create some complications because firmware, it is actual real-time operating system nowadays. To be honest, firmware, it is 6 million lines of the code in your modern laptop, actually more than 6 million lines of the code. And nowadays, in Intel's kernel, even smaller than that. And such of the operating system executed before main operating system, which is getting control later. And of course, this code need to be verified and monitored. Otherwise, it's hard to trust everything which is executed afterwards. And also the threat modeling for the hardware, firmware, and operating system, it's completely separated. If you think about, we have a 3 different ecosystem where the hardware vendors developing the hardware security features, and then the firmware developers try to implement the support some of these hardware security features in their code, and operating system developers, which is completely separate teams, separate groups, or separate companies, try to build something on top of that. And this creates a lot of complications because we don't have unified software stack, which is where the protection is united, right? And of course, as we go down to the stack, we have a lack of threat intel signals because we don't have much visibility there, we don't have much data, we don't have much interfaces to actually produce such of the data for investigations, forensics, and actually protecting the users in our modern infrastructures. And of course, platform boot process is also very complicated, and it is just get more and more complicated getting upper to the stack. So, and complexity is growing. Another good example of this broken disconnection, it is this driver, which is developed by one of the vendors and actually correctly signed. This driver introduced some of the vulnerabilities which is easy to exploit. It's been classical Stack Overflow, and it can be abused for actually delivering malicious payload and bypass the secure boot. And this causes all movement of boot hole attack vectors, right? So I think one of the main lessons learned, signed, it doesn't mean trusted. And to be honest, it is a completely different problem where we have a lot of signed drivers, which is contain vulnerabilities, which is can actually be abused to bootstrap and deliver malicious code to some privileged mode like a system management mode or even others. And another example of vulnerability on HP Proline server, which is actually has also some memory corruption vulnerability and allow the attacker to bypass secure boot integrity. So also that remind me very old problem with MS16100, which has been called Golden Key and presented in 2016 at DEF CON. Basically, vulnerability allows the attacker to bypass the security feature by using actually signed boot manager, which has been vulnerable for some of the problems, and actually allows the attacker to bypass Windows security features. And this bootloader version can be reused with other operating system because it's signed by Microsoft, right? And before of that, it's been actually a huge problem. So we blindly trust any code which is come from the trusted source, right? So if the code signed and come from the trusted source, we just blindly trust any code like that. And it's create a lot of complications from the industry because we don't have an ability to understand what is inside this signed code, right? So basically, what's happening right now, industry overloaded with integrity solutions for the firmware, but these integrity solutions provide zero visibility about their alerts, right? But let's talk about ecosystem of modern x86 hardware and actually complexity of supply chain. We have the hardware vendors, which is actually developing the hardware, and on top of that, we have independent BIOS vendors, which is developing some sort of frameworks. On top of it, device manufacturers developing their code. So basically, we have the hardware vendors delivering the reference code to independent BIOS vendors, and then they, on top of that, developing their code, right? So, and device manufacturers actually providing less than 10% of initial code base, and original equipment manufacturers shipping these firmwares and hardwares. I can't say blindly, but it's a lot of blind spots in terms of this complexity of supply chain, because like we trust what is inside reference code, we trust what provided by IBVs, and in the end, we have a device manufacturers which can introduce also other problems. So this complexity of the supply chain create a lot of blind spots for introducing known vulnerabilities or complicate patching, introducing new vulnerabilities and complicate patching known vulnerabilities. And this huge problem for the industry. And to be honest, complexity of modern firmware supply chain is only growing and get more complicated and not controlled by any single vendor completely. So, but let's talk about more how firmware developers and hardware companies looks on the identification such of the threats and what they're doing. And of course, here is a big disconnection between development teams, architects who design security features, and actual implementation. And as we can see, basically creating the threat model just based on the Stride and other frameworks for threat modeling, it is not enough. Actually, we need to understand what's the attack surface, not only today's state, we need to understand what it will be tomorrow on the hands of the attacker, just to predict and mitigate such of the threats correctly. And of course, this framework doesn't provide that ability and need to be modified for to be more connected for current industry needs. And another problem, I think, for the industry, we also try to make a lot of security by obscurity. I think actually open source security firmware foundation making a lot of movement to make more popular between the vendors development processes for open firmware, right? So we have a lot of activities on OpenBMC, we have a lot of activities on the core boot, and I hope it will be more transparency on the firmware level in general, because it's very important. And security by obscurity, it never works, right? So, and if we have a firmware binaries where we have stripped function names, it doesn't remove a lot of other symbolic information, which can be analyzed by the analyst and understand the behavior of the function. And of course, it's not removing the vulnerabilities which is inside the binaries, right? So, and it's just create much more problems and actually complexity of debugging of the problems than actual profit for protecting the users. And also another statement, basically security researchers are decompiling the binaries And of course, yes, but if you think about current reverse engineering frameworks, it's very effective. And if you look, it is actually a screenshot from one of the functions from UI5 firmware, Dixie driver, and it is normal decompilation flow, right? I would say it's okay, but it's not really readable, right? So, but after the plugin, which binarily team supported, called EFI Explorer, it's completely open sourced on GitHub. So EFI Explorer provides some semantic annotations and makes this code much readable and provide you some additional symbols based on constant and a lot of code context, which can be extracted automatically. So, and these functions and actually look pretty close to the original logic of the function in the source code. And analyzing these functions is pretty easy. That means like security by obscurity doesn't work because we have a lot of already novel, we have a lot of novel techniques to code similarity for symbols reconstruction and a lot of other stuff, which is, of course, providing modern reverse engineers a lot of new tooling and make their work more effective. It's why we need to think how we can protect and mitigate firmware threats more effectively with current reality and don't try to come back in early 2000s and think about security by obscurity as a security feature. Also, another story, it is about few vulnerabilities which we presented earlier this year with my colleagues from NVIDIA. So basically, we found few vulnerabilities in Dell PowerEdge server, and one of them in Crystal Reach Dixie driver, another in platform initialization driver. One, it's actually classical Stack Overflow, and another it is a heap overflow. But it's already actually well documented in our slides from Black Hat Vegas this year, and also you can find binary blog post explaining these problems. But interestingly, why this problem on these slides, I want to show you how current state of modern exploitation for the firmware it looks like. So first vulnerability, actually, it's just get some UEFI variable, which can be controlled by the attacker. Attacker can write to this UEFI variable, and it can cause some heap overflow and corrupt the memory, and in that attacker can lead the code execution. So this Crystal Reach Dixie driver, it's quite interesting because it is tied to the new type of the memory developed by Intel. And of course, this new type of memory can be used by an attacker to actually abuse this vulnerability. And it's been stay unpatched quite a while, to be honest. And exploitation, it's not very complicated, but also, which is more scary, this vulnerability bypass any sort of integrity checking, and the attacker can, in runtime, get execution which will be not detected by any sort of health attestation based on the TPM, because TPM PCRs can be extended in runtime. And of course, both of these vulnerabilities is actually providing some sort of context about how it is easy to bypass modern boot integrity process and boot verification process. And secondly, actually cross the security boundaries where we execute the code and can trampoline to the operating system and attack from the lower stack, the upper stack effectively. But we don't even need to exploit these vulnerabilities, because it's been another bug we found together with NVIDIA team, and Intel BSSI DFT, it's been a feature, was designed to run some arbitrary unsigned code stored in UEFI variable. But of course, it's Intel reference code, and this feature been actually probably developed for debugging reasons, but in the end, not all the vendors been effectively disabling this feature, which is of course tied to the supply chain problem and can cause a lot of security failures in modern data centers infrastructure. So all the details about this vulnerability you can find in our Black Hat slides and also binary blog called Attacking Pre-FI Ecosystem. But in short, this vulnerability allows the attacker to write up to 100 kilobyte binary blob, which can be executed during the platform initialization phase. And it's pretty early phase where the hardware gets initialized, and system management mode and Dixie, it's not initialized yet. So attacker have an ability to influence a lot on later phases of the boot process. And this, because it's actual design feature, it's very stable way of get the code execution, right? And it's quite scary. Such of the APOC and design problems, it's actually create very complicated problems in detection and response for the modern hardware ecosystems in the data centers. And of course, the same problem, it will be not detected by health attestation or TPM because PCRs will be not extended, and these registers usually stored the hashes, right? So, and basically these hashes are pre-calculated, and any runtime exploitation bypass such of the technology easily because it just not been designed to detect any sort of exploitations like that. And of course, as we discussed before, a lot of vendors don't disable this feature because it is being introduced for debugging purposes. But interestingly, it's been another logical bug caused in Intel reference code where the function which need to be emulate physical presence of the jumper and returning some of the information about if activity of this feature of BSSA DFT, it's been always returning true and cause some problems because it's been hard to detect it, it's been failure logic. And as you can see, it's not been, this vulnerability not been attacking the single vendor, it's actually caused the whole industry problem where a lot of different vendors get vulnerable for this vulnerability. And actually, of course, different vendors have a different patch cycles, and all of this reflecting on ecosystem. And basically, even single vulnerability in the Intel reference code can cause outage of many, many, many other platforms. And we see here, it's not only vendors, which is just the usual mainstream enterprise vendors for the laptops. It is actually servers, it is critical infrastructure and network appliances. So we blindly trust everything which is baked in silicon, and not only to the firmware, because we don't have a tooling, we don't have an ability to verify our hardware. And we have some sort of hangover from the past where actually we already hear the story about the Bloomberg and Supermicro, also counterfeit devices is not rare, and F-Secure Labs actually been providing very interesting story about fake Cisco appliances with actual backdoors in it. So I think it's a lot of new challenges for the industry to fix such of the problems, but I think we need to find the complex way how we can stop the modern attacker and don't let them hack modern infrastructures, because it's make a lot of it gives them too much power to influence in our companies and actually our lives. And this is my thoughts, and thank you very much for spending some time at today's morning. And I wish you the happy SINCON 2021. I see a lot of interesting topics in the agenda, and it's been a big pleasure for me to be on the stage again. Thank you very much. Bye-bye.
Thank you very much, Alex, for the insightful keynote. All Q&A with our speakers will be done via Discord, so make sure you get on it. And that's it for SINCON 2021 keynote segment. Starting at 11:30, we will be starting our 3 tracks, our main stage, workshops, and open BizCom track. See you all then.